Assalamualaikum and good morning everyone. Today I will present to you for chapter 1 and 2 understanding in subject electromagnetism through vector analysis. This chapter will be presented by me. My name is Azizan bin Fadillah and my metric number is 2023616624. Okay, for the introduction to electromagnetism and vector analysis, I will briefly present the basic concepts of electromagnetism and vector analysis. These topics are closely connected because electromagnetic quantities such as electric and magnetic fields have both magnitude and direction. Therefore, vectors and vector calculus are important tools for describing and analyzing electromagnetic phenomena. For the electromagnetic model, electromagnetism is a branch of physics that studies the behavior of electric charges and the relationship between electricity and magnetism. There are two types of electric charges, positive and negative. Charges with the same sign will repel each other, while charges with the opposite signs will attract each other. A stationary charge produces an electric field around it. When the charge moves, it produces an electric current, and this creates a magnetic field. A changing magnetic field can also produce an electromagnetic force or EMF. This shows that electricity and magnetism are not separate phenomena but are connected as one electromagnetic field. Electric and magnetic fields. An electric field is a region where an electric charge experiences a force. We normally represent electric field intensity using the symbol E. Electric field lines move away from a positive charge and towards a negative charge. The number of electric field lines passing through a unit area is represented by electric flux density. It was D. A higher flux density indicates a stronger electric field. A magnetic field, on the other hand, exists around a permanent magnet or a current-carrying conductor such as solenoid. Magnetic flux density is represented by B and measured in Tesla, while magnetic field strength is represented by H. Unlike electric field lines, magnetic field lines always form a complete closed loops. The fourth slide is the electromagnetic waves and light. Electromagnetic waves produced when electric charges or electric dipoles oscillate. The oscillating charges produce a changing electric field, which is accompanied by a changing magnetic field. In an electromagnetic wave, the electric field and magnetic field are perpendicular to each other. Both fields are also perpendicular to the direction in which the wave travels. Light is one example of electromagnetic radiation. The energy of light can be calculated using the equation E equal to hc divided by lambda. This equation shows that a shorter wavelength produces higher energy, while a longer wavelength produces lower energy. The fifth slide is the fundamentals of vector analysis. To analyze electromagnetic fields, we need to understand the difference between scalars and vectors. A scalar has magnitude only. Examples include mass, time, charge, and energy. A vector was both magnitude and direction. For example, it includes force, velocity, electric field, and magnetic field. Vectors can be separated into x, y, and z components. The dot product produces a scalar and is commonly used to calculate the component of one vector along another direction. The cross product produces another vector that is perpendicular to the two original vectors. These operations are especially important in electromagnetic equation. The coordinate systems. There are three main orthogonal coordinate systems. First is Cartesian, second is cylindrical, and the third one is spherical coordinates. They are called orthogonal systems because their coordinate directions are mutually perpendicular. The best coordinate system depends on the symmetry of the problem. Cartesian coordinates are suitable for rectangular or straight geometries. Cylindrical coordinates are more suitable for objects such as long wires, cylinders, and solenoids. Spherical coordinates are normally used for spherical objects or fields that move radially from central point. Choosing the correct coordinate system can simplify a difficult electromagnetic problem and reduce the amount of calculation required. Okay, for the last slide is about the vector calculus and conclusion. Vector calculus allows us to describe how electromagnetic fields change in space. The gradient gives the direction and maximum rate of increase of a scalar field. Divergence measures the amount of outward flux from a point. Curl describes the rotation or circulation of a vector field, while the Laplacian measures the overall spatial variation of a field. These mathematical tools are used in Maxwell equations, which summarize the fundamental relationship between electric fields, magnetic fields, electric charges, and electric currents. Therefore, in conclusion, electromagnetism explains the relationship between electricity, magnetism, and electromagnetic waves, while vector analysis provides the mathematical language needed to describe this phenomena. Thank you.